Welcome, engineers. My name is Travis IQ, and today we're going to discuss and demo the fundamentals of routing packets. Now, I think Packet Tracer is probably one of the best ways to do this, so let's get after it. So before we do any stepping into the router configs and simulation mode here in Packet Tracer and understanding where the packets are going, we have to know a little bit about what routing actually is. And so what routing is the process of forwarding packets to remote networks. Why do we need routing from this perspective? Well, for example, PC0 here on the 192.168.10 network doesn't know anything about any of the other networks in this environment. PC0 knows, based upon its configuration, and I have a video showing the configs for the basic network configurations here, that it is on the 192.168.10 network, and if I were to tell it to communicate, say ping or FTP or telnet to another host in the 192.168.10 network, it would know that it needs the local address of that device, so a MAC address. It would know how to encapsulate that traffic. If it doesn't know the destination network, so if that destination network is not the 192.168.10 network, then how does this PC communicate across the 10.0.1 network, the serial connection between router 1, the LAN router, and the DMZ router? How does PC0 communicate with PC2 on the 172.16.20 network? How does PC0 get to the internet, in this case the cloud and a DSL modem? The way that this occurs is through routing. The router knows how to get to these remote networks, or it knows, let's say, static default, so it knows where to send traffic if it doesn't know where to send, if it doesn't have that listed network in its route table. Okay, so if this router then, its job is to forward traffic, its job is to route traffic, the fundamentals of routing here. So what happens? PC0 knows to send all of its traffic to the LAN router, and if we looked in the configuration, it would actually have a default gateway of 192.168.10.1. And so PC0 says, oh, I don't know, if you ask me to ping, for example, 172.16.20.4, PC0 doesn't know how to send traffic there. And so it forwards the traffic to its default gateway, and the router makes these decisions. Fortunately for us, because we're going to be doing some of these configurations, the routers actually don't have any routing configs in there yet. And so we're going to set these configurations, and we're going to show how this network is going to perform without routing, without this fundamental technology, and how it will perform afterwards. And so if I were to go into this PC and try to ping 172.16, ping 172.16.20.4, I'm going to get a destination host unreachable. This is actually an ICMP response from the LAN router. The LAN router, in this case, doesn't know how to get there. It doesn't know how to route the traffic. How would that router then know how to route the traffic? Well, the router needs to learn where that network is or how to route that traffic. And there's a few ways to learn this. So routers in the internet or in the WAN use BGP to distribute route information. Routers in corporate environments will use what are known as dynamic routing protocols, things like EIGRP, OSPF, another simplistic routing protocol like RIP, ISIS. These are examples of internal dynamic routing protocols. There is external EIGRP and some external implementations of these as well, but traditionally we think of them as internal routing protocols. And then there's one that we're going to use here because we're doing a fundamentals of routing discussion, and that's going to be static routing. And so what we're going to do is we're going to tell this LAN router here that statically it should forward traffic. We're going to tell it statically, right, that it should forward traffic in this direction to get to this network. And so in that case then, when PC0 tries to ping the 172.16 network, there will be an entry in this router for that network. Let's see what entries we have in here to start with, because the router will populate its route table with routes that it knows about, things like networks that are directly connected. Just show IP routes. And if we look at the routes here, we actually see two routes. Why do we see two routes here? We see two because we have two directly connected routes. And what are those directly connected routes? It's the 10.0.1 network, 10.0.1/30, and the 192.168.10.0/24. And so this is a 2 network address, and this is a 254 network address. So we could put a bunch more hosts in here, right, which is why we have this little switch in here and a couple of hosts. So my question is then, before we even start putting these routes in here, we should probably prove, I guess it's not a question, but we should prove then that we can also ping locally. And so we can use ICMP Echo to local hosts. So if I go in here and I go ping 192.168.10.3, that's the PC1, I should be able to ping PC1, and in fact I can. Because I said that if I want to communicate with a local host, one on the same network as myself, I actually don't need routing at all. Routing is to get to remote hosts. And that's what routers do. And we've already shown the route table. So I also should be able to get to my default gateway, 192.168.10.1, ping 192.168.10.1, which I can. I'd like to do a couple more thought experiments here before I return to these routers and make these configs and make this network work from a layer 3 perspective. And that is to understand how routing works and how we make these decisions even without the route table. So what does that mean? What am I getting at, Travis? What I'm getting at is, what happens if I were to ping this interface right here? So I would encourage you to take a second, maybe pause it here, and think about what would happen here. And I'm going to do this, and I'm going to explain what we see. Should I be able to ping this interface? PC0 doesn't know about the 10.0.1 network. G00 does know about the 10.0.1 network. And so what does that mean for us? I'm going to assume you've thought about this, and I'm going to come in here and I'm going to ping 10.0.1.1. That's the that's a serial 030 interface on the LAN router. I actually can ping this interface. Why? It has to do with the route table. I actually already showed you the route table. If I go back in here and I look at the route table of this router, what happens here when I ping the serial 030 interface of the LAN router? What happens is PC0 on the 192.168.10 network goes, I don't know where the 10 network is. Where do I send traffic if I don't know where the 10 network is? I send it to my default gateway. It forwards traffic to the default gateway. The router then goes, okay, I see the destination IP of 10.0.1.1, and it looks it up in its route table. Do I have an entry for the 10.0 network? I do, and in fact, it's actually a local route in my route table, which means it's a local interface, 10.0.1.1. That's this interface. The router goes, yes, and the router responds with an ICMP Echo response because it knows about that network. So although it's a remote network to PC0, and the router doesn't have any static routes or dynamically learned routes, the router actually automatically learns directly connected routes, and in which case it knows where this host is, and in fact it recognizes it as its exit interface on the serial 030 interface. Okay, interesting, but not as interesting as the next question. Another question where I would encourage you to take a second and think about this is, so now if PC0 tries to ping verify connectivity to the serial 031 interface on the DMZ router. PC0 does not know about this network, so it will forward the traffic here. I would encourage you to take a second and think about this. That being said, the LAN router does know about the 10 network, and so the LAN router should forward that traffic in that direction. So what do we see when we actually conduct this ping? 10.0.1.2. We don't get a destination host unreachable. Why don't we get a destination host unreachable? Because the LAN router knows where to forward that traffic. We get a timeout. Why do we get a timeout? I think that this is actually a really good place to enter our Cisco's simulation mode. So let's go forward in time a little bit here, and we look at this ping, and it's actually timed out 4 times. If we go into simulation mode, this actually stops time for us. And now what I can do is I can generate this ping again. And you can see that the ICMP echo request is generated by PC0. It's then forwarded to the switch. The switch looks the destination MAC address up in its MAC address table. It forwards it out the FA01 port to the LAN router. The LAN router then looks the destination network up in its route table. It looks up in its route table and it knows that the 10.0.1 network is out the interface 0030. It forwards that traffic to the DMZ router. The DMZ router then processes the ICMP echo request and doesn't know where to send the response. This is where it gets interesting. This is where we have to think about how the routing process works. Because if we look at this broken ICMP echo response, right, or non-existent, what actually happens is the DMZ looks it up, right? Just as we understand all of these routing processes now, it looks it up in its route table. What entries should we see in the DMZ's route table? The DMZ's route table should contain a directly connected route of the 10.0.1 network, and it should also contain a directly connected route to the 172.16.20 network. If that's the case, and I'm going to turn off the simulation mode here so we can actually pull those route table entries. If that's the case, then this DMZ router is trying to respond to an ICMP echo request from 192.116.10.2. It looks the source address up, or it looks at the source address from the ICMP echo request. It looks that source address up in its route table, and what does it find? It finds no entry for the 192.168.10 network. If it doesn't know how to respond to the 192.168.10 network, then what happens? Well, it actually sends a destination host unreachable back to the LAN router, but the LAN router doesn't know what to do with it because the LAN router wasn't the source anyways. So you don't receive a destination host unreachable, you don't receive an ICMP echo response, you don't receive anything. And so without routing in this network, I actually have a really interesting scenario here where I get a request timeout, but no actual response from any of the hosts because the DMZ is only sending a response back to the LAN router. The LAN router doesn't care because it's not the source. So if we go back here and now I issue a show IP route on the DMZ router, in fact, it is the case. The DMZ router only knows the 10.0.1 network and the 172.16.20 network. So it doesn't know how to respond to the 192.168.10 host. And then finally, if I wanted to, I think we already showed this, but if I wanted to ping all the way across the network to the 172 host, right, if I pinged all the way across the 172 host, we already shown this that the destination host is unreachable. So we actually have three completely different scenarios. We ping one remote interface and get a response. We ping another remote interface and get a timeout. We ping a third remote interface and we get a destination host unreachable. So this is a really interesting scenario that illustrates a lot about how we need to think about the router and the route table to illustrate what's actually going to happen, and so we can troubleshoot in the future as well. That being said, now that we've produced some interesting scenarios, let's actually go through and make this network work. So the first thing that I want to do is add a route statement. And so the way that I add a route statement to the LAN router is configure terminal, IP route 172.16.20. 255.255.255.0, 10.0.1.2. So now this is saying that the 172.16.20 network, the entire 172.16.20/24 subnet, should be forwarded towards the 10.0.1.2 IP address. So that's known as the destination IP. If I do show IP route, the 172.16.20 network via the 10.0.1.2 address, which is this address right here. Now that I've given you a little bit more information, can I ping the 172.16.20.4 host. This is something that I would again encourage you to think about. Maybe take a second, pause it here if you wanted to. That being said, I'm going to conduct this ping, and I'm going to put it in simulation mode so we can actually watch it here. So I'm going to ping the 172.16.20.4 host. And as we move forward, we go through the LAN switch, we go through the LAN router. The LAN router now knows how to get to that remote host when it did not before. The remote host, 172.16.20.4, responds. It sees an ICMP echo request from the 192.168.10.2 host, and it then responds to the 192.168.10.2 host. What happens? Does PC2 know how to get back to the 192.168.10 network? It does not. But PCs have default gateways, so PCs know where to send traffic if they don't have an entry in their local table for that remote network. And in fact, that is the default gateway. And so PC2 sends that traffic back to the DMZ router. And what happens at that point? The DMZ router, again, just like before actually, and now it happens a little bit differently because the packet makes it all the way out to the 172.16.20 network, but it still gets back to the DMZ router, and the DMZ router does not know where the 192.168.10 network is. If the DMZ router doesn't know where the 192.168.10 network is, it generates an ICMP host unreachable packet and forwards it off. Like, I don't know how to get there. But again, what actually ends up happening is it's forward back in this direction, and so PC0 never receives it. So we're going to receive a timeout again. So if I go forward in time here, just go back to my real time and I look at the pings, what I'll actually see is timeouts. And if I move forward a lot forward in time, I'll see all 4 of those timeout. And so we see a very similar mechanism to what happened when we ping the DMZ router interface, but it's actually from a different perspective because now the LAN router can actually forward it out in that direction. So what are we missing? What are we missing, Travis? We're missing a route back. Yeah, that's it. We're just missing a route back, a return route. And so now the LAN router knows about the LAN network, the serial network, and the DMZ network. And the DMZ router knows about the serial network and the DMZ network, just not the LAN network. So we just have one static route left to enter. So let's do it. So we need to enter the global config. We need to enter a route statement for the 192.168.10.0 network. 255.255.255.0. And we need to specify a destination IP, 10.0.1.1. To show IP routes, we now have that route statement entered, and we now have 2 fully specified routers that know about all 3 networks in this small corporate environment. As such, I should be able to ping from the 192.168.10.2 host to the 172.16.20.4 host or the 172.16.20.5. But for continuity here, we'll first ping the .4 host. And in fact, I do receive responses. I actually have my TTL decremented, so the time to live decremented by 2. It starts at 128 and goes through 2 hops. So we would actually, we're seeing everything that we would expect to see in this environment. Let's make sure that I can get back as well. So let's ping from the 172.16.20.5 host. Ping 192.168.10.3. Sorry, we need to move forward in time. We had 1 request timeout. That's actually due to ARP, probably, in the local network there with the switch in the router. But if we did this again, we won't see the second timeout. So if we did it the second time, we'll actually see all 4 succeed. That was due to ARP initially. That's another process we can discuss for another time. So now the entire network is specified. Any host can ping around from any host to any other host. We could talk about things like filtering traffic with access control lists. We might want to talk about how to get off of these networks to the internet, for example, as something like a static default route. And that actually I will include here. This will be the last thing that we discuss here, and that's static default routing. And so the question is, how do we get out to the internet, right? What if I wanted to ping, Google's DNS 8.8.8.8 or something like this? And in this scenario, if I wanted to do that, if I wanted to add a route for every other IP address that isn't in this network that says, hey, if you don't know it, router, then forward it out this interface and we'll send it to the WAN and the ISPs will handle the routing from there. Then what I would want to do here is actually enter a static default route. And so a static default route actually looks like this. IP route, so I'm routing for all networks, 0.0.0.0, and I want to match all of those networks as well. So my subnet mask is 0.0.0.0, and I'm actually going to send this out, right? I'm going to specify an exit interface, which is actually going to be G00 here. It's probably going to give me a warning because you really don't want to specify Ethernet interfaces, broadcast interfaces that can have multiple destinations as an exit interface, but we're going to do it anyways. Default route without gateway, if not a point-to-point interface, this could impact performance. So in the future, we can use this diagram to facilitate things like port security and other security topics, access control lists. We can use it to facilitate the discussion of things like static routing or other dynamic routing protocols, as well as adding in some other capabilities like servers and peripheral services, voice over IP. But for now, this is a great fundamental start. And that's what I'm going to leave you with. But as is always the case, I'd like you to engineer, break stuff, and have fun, and we'll see you next time.